Today we're going to solve quadratic equations by factoring. So our objective is that you're going to apply factoring techniques in order to solve a quadratic equation. You're going to find the roots of a quadratic or find the zeros. So we know by graphing a quadratic that it crosses the x-axis either 0 times, 1 time, or 2 times. Those points where it crosses the x-axis, they can be called the solutions to the quadratic. But they can also be called the roots or the zeros. So right now we have different names for those spots. We can call them the solutions, we can call them the roots, or we can call them the zeros. When we want to know what the solutions are exactly, we need to use factoring techniques. Now, in past classes, we have used factoring. And the first thing we should do when we factor is we should look for the greatest common factor, or the GCF. In order to use the GCF, the quadratic must be equal to 0. If not, we have to move all the terms to one side of the equation. We have to divide the largest number and variable out of each term. When you do that, we're going to take that GCF and write it as a multiplication problem. That GCF is on the outside, and the quotient, whatever we're left, is in the inside of the parentheses. Both of these are called factors. We're going to set each factor to 0 and solve for the variable. So when I look at this first example, do I have everything on one side and it's equal to 0? I don't have to move anything, it's already set up for us. What is the largest number I can divide out of 16x squared and 48x? What is the most variables I can divide out of both? So in this problem, I can divide a 16x out of each term. So 16x is my GCF. Now, when I divide by 16x, my quotient is x plus 3. I'm going to set each of those equal to 0. And solve for my variable. So I would divide by 16 to get x equals 0. And on the other one, I would subtract 3 to get x equals -3. These two numbers are where my quadratic will cross the x-axis. So these two numbers are called the solutions, they're called the roots, and they're called the zeros. Let's look at the next example. Do I have all my terms on one side equal to 0? Yes. So now I have to look at what's the largest number I can divide out of each term and what's the biggest variable I can divide out of each term. Because this first number is negative, I want to divide by a negative number. And I can divide each of these terms by -5x. So -5x is my GCF. Your GCF is always on the outside. Now, what I'm left with, when I take -5x squared and divide by -5x, I'm left with an x. And when I divide 20x by -5x, I'm left with -4. I'm going to take each of those factors and set them equal to 0. I'm going to solve for x. So I'm going to divide by -5. And on the other factor, I'm going to add 4. These two numbers are where this quadratic crosses the x-axis. These are the solutions to this quadratic. These are the intercepts. These are the roots. These are the zeros. Remember, these three words all mean the same thing. All right, last example. Do I have all my terms on the same side? No. So I need to move them. I'm going to move my 28x because I don't want to have a negative leading number. So my problem is 0 equals 7x squared minus 28x. And now I'm going to look for a GCF to divide out of both terms. So what number can I divide out of both? How many variables can I divide out of both? I can divide a 7 out of both. I can divide an x out of both terms. So 7x is my GCF. Now what am I left with? If I take 7x squared and divide by 7x, if I take 28x and divide it by 7x, these are my factors. If I take 7x and set it equal to 0 and x minus 4 and set it equal to 0, I divide by 7 and add 4. So again, on this problem, similar to the previous one, I have two answers, x equals 0 and x equals 4. Okay, again, I want to remind you that what this is telling me is that if I graphed this, my quadratic would be crossing at 0 and at 4 these two numbers are my solutions.